Hi guys, welcome back. In this video, I would like to share with you the top secrets of how the social activity component in our DPoI Importance score is calculated. For those of you who don't know what is DPoI Importance rate, we already have our first video where I explain in details what is the overall importance rate. So please refer to the link down below this video to watch the previous video. In this one, I would be explaining to you, I would be focusing on one component of the overall importance rate, the social activity component. What is the aim of this video? First of all, we would like to dive into mathematical details of how your social activity rate is calculated in such a way where we don't just provide you like the formulas and like complex stuff and that will just hurt your brain maybe, but that will give you the intuitive idea of how it is calculated and why it is calculated in such a way, so that when you go to the platform and you perform some social activity, you have a clear picture in your head of how it will influence your social activity rate. Social activity component is a very important component in your overall importance score. Why is it so important? Social activity on different kinds of networks and in different sorts of digital communities not only serves as a precursor to economic activity and propels network growth. Apart from that, social activity of the users on the network brings other important resources to this network, such as new ideas, new information, opinions, contacts, friendships, inspirations and ideas. Quantification of the value that your social activity brings to the network seems to be a natural step in the development of the consensus algorithms on blockchain. Such quantification allows you to receive a reward, direct financial token reward, from your social activity on the network, and also build a transparent and clear reputation in different types of communities. Let's consider several use cases. Imagine, for example, a stack exchange on blockchain, right? So you're performing some activity, you're answering some important questions, you're solving some programming problems, and other users upvote your commands because they think that it's really good, it helps them. This is direct quantification, right? And you would be able to receive a token reward for the fact that other users find your activity useful, because our consensus algorithm directly accounts for that, right? Or another example would be a GitHub on blockchain. For example, in a real GitHub, in a centralized GitHub setting, you don't really even have a clear quantification of your GitHub reputation, right? And so you do something, but you're not only not receiving anything for it, you don't even know what your reputation is. And here you actually do know it. As I already mentioned, your overall importance rate consists of sum of three components. The value of stake, the share of your social activity, and the share of your economic activity. So let's look at the actual formula. So this is your overall importance rate. So it's equal to a certain weight that is multiplied by the value of your stake, and in this case, your stake value is calculated in a very simple way. It's just the amount of stake that you have on your account, plus another weight that is multiplied by the social activity index that is calculated by the algorithm that we're going to discuss in details in this video. And then plus another weight multiplied by the economic activity index that is calculated using a slightly different algorithm, and we are going to discuss this algorithm in a separate video. So the total sum of these three weights is equal to 1. So you basically can think about this weight as a percentage, the proportion. And these weights can be regulated by the community. Basically, you, as a community, you can vote for how much weight you want to assign to the stake value of the user, how much weight you want to assign to their social activity share, and how much weight you would like to assign to your economic activity share. So now let's focus on the part where we compute the social activity share. First question that you probably want to have an answer to is what is the input data for the algorithm that computes this value? The input data here are the social transactions that you perform on many kind of decentralized applications that you can deploy on our blockchain. For example, uCommunity is one of such decentralized applications that we developed. It serves as a content platform where you can post all kinds of content, and other users can perform one type of social action right now, which is upvoting your content. Pretty much your posts and your comments. So those upvotes are recorded in the blockchain, they're timestamped and recorded in the blockchain as transactions and stored on the nodes in the framework. And every time that the algorithm computes the social activity share, it pulls up those transactions from the blockchain and uses these transactions as an input to the algorithm. The computation of your importance rate and obviously your social activity rate as well right now happens in a cycle every 300 seconds. Let's consider this visual analogy. This is your account, and these arrows, they denote the incoming upvotes from other users, right? Like upvote 1, upvote 2, and upvote 3. This is really important to understand that your social rate is calculated based only on the incoming activity from other users. No matter what outgoing activity you perform, like you upvote other people's posts or you repost them, this doesn't matter. This doesn't influence your own social rate. Why? Because the outgoing activity of the user should not influence the social rate that they receive. The social rate here serves as an evaluation of your utility to the network done by other users. Let's briefly talk about what blocks of transactions are used in computation. So there is this concept called transactional window. Let's consider this visualization. This is the present moment when the algorithm computes the social activity rate component. And this is some point in the past. And this is the window of transactions that happened between now and that fixed point in the past. The height of this window is called the transactional window height. So this height is a parameter in the algorithm that can also be changed by the community. And within this fixed window, all the transactions in the blocks that fall within this window will be taken into account in a current computation. The weights for each upvote transactions in this window that I talked to you about are stored in a special matrix called V in our yellow paper. Each element of this matrix is either some number between 0 and 1, or 0. It's going to be a number between 0 and 1 if the account J uploaded some content I within this transaction window. And it's going to be 0 otherwise. The important point here that I want to talk to you about, guys, is that those weights of different transactions in this window decay. What does it mean? It means that the newest transactions that happen now will have the highest weight. Actually, the transaction that resides at the level 0 will have the weight 1 if you put 0 in this formula, right? So the older the transactions, the less weight they're going to have. And in this graph, we show you that every D blocks, right? This is like the length of another window, like a block window. The weight of the transactions that belong to this block interval will decay, right? So these are going to be the most newest transactions. These are going to be the transactions that happened in the past. The transactions that happened in the further past. Why we're using decaying weights for all of the transactions? Because when the weight of the transaction decays with time, it allows to make any fraudulent activity on the network only temporary. Hi guys, so I just explained to you what matrix V is. Just one more time, matrix V represents, each element of matrix V represents the weight of the transaction that a certain user gives to a certain account. And this weight is going to be between 0 and 1. That's the meaning of the elements of this matrix. Now, there are two other matrices that participate in the algorithm that calculates the social activity rates. These are the matrices P and matrix R. Matrix P simply reflects what content belongs to what account. And matrix R reflects the history of reposts. So if you are on your community social platform and you hit repost of some content, it goes to your wall, and then someone upvotes that repost. Those upvotes, they don't go towards your account, they go towards the account of the original author. This is really important for you to understand, right? So you can repost someone's content, but if someone upvotes it, this is going to be the score that goes towards the author, right? And so using this matrix, we obtain the matrix V prime that basically just takes into account the reposts of the original content and redirects the weights of those reposts back to the original author. So I just explained you guys that matrix V basically connects the content and the account, right? Because it contains the weight of the operation, the transaction from the account towards a particular post or comment, and this operation is your upvote. But what we want to do is we want to make a connection between one account and another account. So your account upvotes many posts of different other users. It can upvote several posts of one user in a given time frame. And we would like to reflect this in our calculations. How do we do this? We do this in the matrix U hat, and here's the equation of a single element in this matrix. Basically, this single element represents the weight that one account in the networks gives to another account in the network. What is going to be this weight intuitively? I'm using this schema here to explain this to you guys. So this is your account, it upvotes many different posts of this another account. And you can do it during a certain period of time. So some of your upvotes will be older and some of your upvotes will be really recent. So you're going to be giving different weights to each of these posts in the transaction, right? You remember that the newest upvotes will have the highest weights, and with time, the weight of each transaction decay. So this post will receive, for example, 0.5. This post will receive a weight of 0.2, and this one will receive a weight of 0.1. And the width of the arrows here represents the difference in those weights. And so you are giving this weight to the account. In our algorithm, the weight, the overall weight that you are giving to this account will be the maximum of these 3 weights. So it's going to be 0.5. Why we choose to do it in this way? Because we don't want, we want to avoid the situation where an account receives a high weight from another account simply because there are many posts that were upvoted, right? This is a potential vulnerability, and this is a potential weakness where that can be utilized by the attacking node, an attacking user or a bot. And that's why instead of taking the sum of those 3 weights, we're going to take the maximum value. And so this is going to be this weight of that one account gives to another account. So I just explained to you guys how we get the matrix U hat that basically connects one account with another account. And now I want to look a little bit closer on the structure of this matrix. First important property of this matrix is that the diagonal elements are going to be 0 because the account doesn't upvote itself, right? So you cannot give an upvote yourself. So these elements are always going to be 0. There is a little problem that if an account doesn't have any outgoing activity for a long period of time, some of the columns in this matrix might just be all zeros. And this is not good for our algorithm because it means that the sum of the elements in the column is not going to sum to 1. So this matrix is not going to be a stochastic matrix. And if our matrix is not stochastic, our algorithm will not converge. So right now I'm talking about the PageRank, classical PageRank algorithm that we're using to calculate social activity rates. If this matrix is not stochastic, the algorithm is not going to converge. In order to resolve this problem, we add one more so-called hidden account. This hidden account simply gives equal rates to all other accounts, except themselves. So this is the same as adding the rows of ones, 1, 1, 1, 1, 1, in this matrix. Great. So the stochasticity now is guaranteed. The algorithm is going to converge when we do another operation, when we just make sure that all of the elements in the columns are going to sum to 1, right? So we standardize it, the matrix, and this is our final matrix U that is stochastic. It's suitable for our algorithm, and it contains the information about the relationships between each 2 accounts in the network. Okay, so finally we get to the point where I'm going to talk about the actual calculation of your social rates. The vector of social rates for each account are calculated together, and they are calculated using a classical PageRank algorithm with a small modification that I'm going to mention here. Why we're using PageRank algorithm again? Because it gives a way to objectively quantify an account's utility to the network based on the incoming activity from other users towards this account. This is the equation for the PageRank procedure. As you can see, this is an iterative procedure. With each iteration, the algorithm converges towards the final values of your social rates, starting with some initial values. And as I just told you, we now know that the algorithm will converge because of the operations that we did with this matrix U here. You can also notice that there is another matrix in this equation. It's matrix T. It's called a teleportation matrix. It's a complex name, but what is the intuitive meaning of this matrix? In the PageRank algorithm, matrix T always denotes the priorities that we give to each account. And in classical PageRank, those priorities for each account are distributed equally, right? In our procedure, this is the modification that I'm talking about. These priorities are not equal. These priorities depend on two features of each account. First feature is the amount of stack that this account has, right? This is some number. And second feature is so-called validity of your account. And this validity value is calculated based on the special network that we implement. It's called a trust network. If you go on your community app, on someone's profile, you can see a button there called trust, right? So you can trust another user, right? This operation will influence the values of validity of this user, right? Intuitively, you kind of can think about it as, well, if many users trust me, then my validity is going to be higher, right? So this is the intuitive meaning of this. We're going to talk about the trust network and how these validity values are calculated in details in a separate video. But for now, this is really what you need to know. And so the validities and the stack will influence the priorities for the accounts in different ways, because there are weights, right? So you can say, oh, the validity of the account is more important, or the stack amount of the account is more important. This is up to the community to decide, okay? So this is how this matrix of priorities is formed and then used in the PageRank procedure. Okay, so now we calculated our social activity rates using the PageRank. And we just have two post-processing steps that we need to perform to obtain the final rates. The first post-processing step is we want to subtract the stake contribution from the value of your social activity rate. Because we don't want your stake to influence your social rate. We only want the incoming, incoming transactions, incoming activity from other users to reflect your social activity rate and not your own stake. And that's why we do this operation using this formula. And then the second post-processing step is we need to remove the hidden account. Remember, we used this hidden account in order to guarantee the stochasticity of our account matrix. Now we need to remove it, but if we remove it, it's going to change the norm of the social activity rate vector. So we need to standardize it again so that the sum of those rates is going to be 1. Okay, so this is your final value of the social activity rate that you obtain. Apart from your social activity rates that you see on the platform, we also have a rate of the content next to each post. You can notice it in the right upper corner if you go to someone's post or your own post. How we calculate this rate of the content, we calculate it based on your rate of the accounts and the matrix V prime that I described to you previously. This is how you obtain this number. And at this point, I'm going to wrap up. Thank you for your attention. We hope that this video will be informative, understandable, and useful for you. We wanted to make it as intuitive as possible to provide you with the information on how your social rates are calculated. We are really interested in your feedback, your comments, questions, you know, any constructive critiques, opinions about the algorithm, anything. It's really something that we would like to see. So see you next time, and till then, bye-bye.